Hey guys, how are you? Yeah, I was. Yeah, some of you didn't make it to the review class yesterday, but I was just suggesting that don't take the midterm until the afternoon. I mean, unless you're a real morning person and all, you can do the class and get together in a group, maybe over lunch, and because you got until midnight to take the test. Well, I mean, not strictly speaking, 1 hour before midnight. Yeah. Well, we don't have to start right now, as usual. So you guys carry on with the conversation. Well, would you prefer if I basically just muted myself and stepped away for about 10 minutes? Would you prefer that? Meaning that you'd be freer, or sometimes people say professors will cramp your style. But I don't care how um, no, I don't care that what you say, right? It doesn't matter to me. So you shouldn't let my presence cramp your style. But if it does, I'm happy to just mute myself. Right? You guys want 10 minutes while we wait for the other students, so you can just carry on a conversation. Oh, unless you want me to stick around, you can also ask me a question that, yeah, ideally, you can't save up until the other students come. If it's a generally useful question, save it up until later. We'll just play it by ear. Anyone can basically speak up or say anything, and and keep the airwaves occupied until a few more people join, or at least it's just 8 o'clock. How about 8:10, right? But can you guys keep talking so that someone who joins the meeting, if I step away, I don't want someone who to join the meeting and say, oh, well, maybe there's no class today because it's a midterm and this is just a group of students. You want me to step away for 10 minutes? Yeah, you can carry on. I mean, in fact, you can let that be an opportunity to come up with interesting questions, right? You can ask each other questions and say, oh, well, let's ask that during class and so on, right? Let's make that, let's make that a habit for every class, right? You guys talk for the first 10 minutes amongst yourself, and decide, on the salient points that you want to be discussed during class today. And also you can, draw straws or something like that and say, if there's going to be coding today, I'd like to go, you've gone already, you can go next, and so on and so forth. Yeah, is that okay? Okay, so 8:10, can we just regroup at 8:10? Yeah. All right.
Sounds good.
Enjoy your conversation.
So how did the review session go? Agnes, were you there?
Morning. Yeah, I posted on Reddit. I don't know how helpful it was, but I posted anyway.
Oh, yeah, I haven't checked yet.
Shoot,
Yeah,
I didn't check that either. Let me see.
Oh,
Yeah.
it wasn't really a review session, to be honest. It was just, ask questions and whatnot. And but basically, the takeaway was that if you've been doing your quests, and I guess coming to lecture shouldn't be too hard because it's mostly conceptual, it sounded like. Alexandra, is that your dog? Sorry.
Oh yeah, I'm sorry.
No, that's super cute. I just pretty much got out of bed, but I have a meeting at 8:15, so I'm gonna to 8:30, so I'm gonna slip out really quick. It's just like a morning stand-up meeting, so I'll come back after that.
Okay, is it past like 30 minutes or something?
It's like, it's like some customer sync stuff.
So
yeah, it's for my work, so don't worry about it. But yeah, I don't know if there were any I was kind of like wondering if you might say like, oh, you should know these, functions, or something like this, but we didn't hear anything like that, so I don't know.
The %10 period 5F, That
Oh
has to
yeah.
do with how it's formatted, right?
Yeah, it's like floating number kind of stuff. I don't know if we're required to know that stuff, but I mean, it's open book, so I'm sure if we were like, huh, what was this %10 thing? Like, I'm sure we can just,
I think
quickly.
that was part of the
quickly-
things that we didn't need to know, but we were just
Yeah.
kind of exploring.
Oh, okay. Yeah, that sounds good.
Did you guys have any particular questions?
I don't know. I feel if we did the quest, then we're ready, right?
Yeah, okay.
I don't know. I'm kind of nervous, but
He definitely told us not to be nervous.
okay.
And then he was like, if you didn't do so well, just come talk to me about it and perhaps, we can set up a second shot or, she's like,
Okay.
just, as long as you've been doing it and he knows that you've been doing it, giving a good effort.
Okay, that sounds good. Thanks for
Yeah,
posting on Reddit. I just looked at it.
yeah. Sorry it was so last minute. I wasn't know that was happening either.
Oh, it's okay. Yeah, I missed that it was between 6 and 7 and I couldn't make it.
Yeah.
No
would've liked-
problem.
I would have liked to come, but yeah, that's impossible.
But
for me.
for the final, we'll try to schedule similarly ahead of time. So
Yeah.
we've
Yeah.
learned.
Yeah.
No problem.
So Agnes, did you see the code Hiram posted?
Ooh, where on Reddit from last time?
Yeah, I hope we do that. That was fun.
Oh, he was saying that I guess he would like to get Google Sheets connected today and then time the functions or something like this.
Oh, that sounds cool.
Yeah, no, it sounded quite interesting actually.
Yeah, and I was looking
Which
forward
I
to
don't
this
know. Yeah, like I was wondering if I don't know, Google Sheets, like, do you need some authentication or like am I making it too complicated again?
Well,
To pull from it.
we have to be logged into like our Google account, and then you can share it with specific people or get a share link.
Right.
So,
But somehow our function's gonna access it or
yeah, if you do the share link, then everyone can edit it at once.
oh, that's right. Oh yeah, if it's open to the public, then I guess.
Yeah.
That makes sense. Yeah, because you don't even need a Google account, do you? Like if you have a link, you don't have to be logged in, it'll just show you as anonymous.
Yeah, I guess so.
Okay.
That's pretty good.
Interesting.
Yeah. So off topic, I was talking about coffee last class, and I found a coffee maker so I could save money on coffee.
Congratulations.
Thank you.
That's like the first step to building the habit, I guess.
Yeah.
I love your dog, by the way. I just watched
I
him lick your
know.
arm, and it was very amazing to me. Hi.
I would love to have a dog, but don't.
Is he like a Chihuahua corgi?
He's like a really long, like, see? He's a
Oh.
dog.
Oh,
Dachshund.
Yeah, he's a wiener dog.
Wow. Maybe it's the color. Yeah.
Yeah, his eyebrows.
it's like a really perky ears for a dachshund.
Yeah, he's definitely a mix of some kind.
Yeah. Oh, there he goes.
Love it. Every time I see sample code, it's like, oh yeah, here's a cat picture. And I was like, what happened to all the dog people?
Okay. Hey, I'm back. Great. So did you guys brainstorm any interesting things that we want to do today? Hey, actually, you know what? We were talking about something that we could do, right? Yeah. Timing your functions. Timing your functions and then basically getting the times into a, copy and entering the times into some Excel spreadsheet or something like that and charting it so that we can see the shape of the curve. I think we wanted to do that. We never got around to doing that, unless you guys have done it on your own. Yeah, have you guys done it on your own already?
No.
Do you want to do it? We can just continue with that code. But it'll also, things that we do here into the code will probably help for the midterm, because so the control structures we're going to use, for loops and things like that, you can basically bring to bear. Basically, practice is what nails these concepts to our heads, right? So I think this would be a good idea. If you guys don't have other things to talk about, what we can do is take two functions. One maybe takes a vector passed by reference, another one takes a vector passed by copy, and neither of them do anything at all, right? Because we're going to keep it all very controlled. So just take the vector, return. So the only overhead is going to be in the passing, in the passing of the vector. In one case, the whole vector has got to be copied because you're passing by value. And in the other case, it's the same overhead because the vector is in one place and you're just passing 4 bytes or 8 bytes of address. So, but for small vectors, this is not noticeable. But as the vector gets bigger and bigger, you'll see that it is actually noticeable. If you pass by copy, then the call itself should take, interesting, right? We're not even timing the algorithm here. We're just timing the call. And so algorithm times, we can imagine, right? It may take, of the order of milliseconds and, maybe seconds, even seconds and minutes and so on. But we're timing just a raw call at the CPU level, which means that could be like microseconds even. And so the only way we can time it really is to make many of those and then divide, right? So and so that way we're going to use this technique to find out what exactly is the overhead in passing by reference. But I don't know if people have done this experiment, right? I have never seen this. We'll do it today. Maybe you can share the info or the results of your experiment, publicly even, and other people might be interested, right? So check it out. So yeah, if you're interested, so that's what we're going to do. So we're going to take these two functions and we're going to time them. And then we'll time them when we pass a vector of size 10, right? Size 100, size, and so on and so forth. And we'll see that one of them has got to be, the time taken to call the function has got to be constant, flat line, right? And the other one, the time taken to call the function should be linear, right? Maybe close to a straight line because, of all the optimizations at the hardware level, but still it should have a positive slope. Right? It should. I think that's what should happen because there is the overhead, right? If I'm passing by copy like 1,000,000 bytes by copy, it has to be copied, right? So so the time has to grow linearly with the size of the vector being passed by copy, right? Whereas it should not go. It should be constant. That's and later on. See, already, I think Agnes was talking about big O notation and things like that. This is really what the basis of the intuition behind big O notation, right? Because look at the two things, right? So in one case, this is how we build it up, starting at 2A. And 2B, we'll have more situations like this. And by the time you get to 2C, it'll be a piece of cake. So, and what we're trying to do really is that, if I pass by reference, no matter how big the vector is, the method is going to take the same amount of time to be called, right? Even though the method does nothing at all with the vector, right? Because if I'm passing by reference, I'm only passing the address where the thing is stored, not how big it is, right? So if I plot it in Excel or Google Sheets, right, it's going to come out like a flat line with zero slope. However, if someone gave you a function and said, call this function and find out whether it's, here's a very interesting interview question, right? So if you didn't know the signature of a function, but you could call it, because when you call a function, if you notice, at the time you invoke a function, you do not specify whether the parameter is being passed by reference or by copy. Yes, you're just passing the name of the vector. When you call the function, right? So you don't know. So suppose someone gave you a header file which has the declaration inside of it. So you don't know what the declaration, what the signature is, right? And then your task is to find out, or devise an experiment, devise an empirical experiment by which you can find out if this function has its parameter passed by copy or reference, right? Well, obviously you can say, const. Well, it has to be const, because you can say if it's passed by reference, like, yeah, assume that the function doesn't change the value and all, right? So using timing. I mean, you got to refine the question, obviously, if you're going to use it in an interview. But I think this is a good start, right? Because it can show you if the candidate's thinking is scientific, right? So meaning, oh, well, if there's a difference, it's got to come out somewhere, right? Maybe you can't see it with human eyes, so I need telescopes, or maybe I need a microscope, or maybe I need to zoom in really, really hard. All these things, right? But approaching it scientifically is what we want, because that's how, if a problem has a solution that can be obtained with computers, this is the way we think about it and eventually arrive at it. I think, other than these flashes, that we just basically test out and see that it works. What is it? Lei is playing with a Nerf gun or something? Is that a Nerf gun?
Oh yes, it's just
Okay, all right. Don't shoot yourself with it.
yeah, it's broken, but yeah.
Yeah. So there you go. Anyway, what were we talking about? Yeah, passing by. We can do that. I think that might be a fun experiment. In fact, if we don't do it now, I'm probably going to do it in class, not for us, for next quarter, because we've passed the point really when we should be timing. I mean, trying out these things, because we have to talk about objects and things like that. So this might be our last chance to play around with just for loops and timing and things. But I'm certainly planning to do it next quarter, right? So we should be able to time and get to the bare metal timing of actually the assembler overhead, not even the CPU overhead of having to copy bytes over. Is anybody interested in finding out? You can just take the screen. You don't need the previous code, right? We can just code. It's like five lines per function. Yeah, we can just code. And again, it'll be practice, right? It'll be practice in starting with a blank slate and just going. Because what you find generally, even with quests, is that getting started is hard for many people, just like English essays or anything. Getting started is hard, starting trouble. And so what usually works is to take something that's already worked and then cut it down, right? Or try to adapt it, even if it means changing it completely, right? So maybe whittle it all the way down to main with nothing in it. Even that is faster than starting with an empty slate. So, however, I think after a while of programming, what happens is that template code is basically in your head, right? So it's main. So you don't have any fear of starting with an empty slate, because you can always put in a main, right? At the very least. And then you'll know what it needs and so on. And hopefully you got some sketch of it that you can just translate into code, right? So we can try that today. If someone is interested, pick up the screen. Ideally, someone who hasn't had a chance should take the screen, right? Or hasn't had a chance in a long time, right? Because I think most of you had taken the screen at some point. So if you take the screen, let's open up an online editor. It could be anything. Replete. I forget. Online GDB, did it give us a Unix shell? Or it didn't, right? Let's try something else. Let's try replete, right? repl.it, right? I believe we used it last quarter, and there was a shell, on this side. And this side you compile the code, and this side you run it, and things like that. I think that was nicer. There's 100 sites like this, right? But I think I'm just pulling out of memory one of the most recent things we did. All right, so if one of you wants to take the screen, let's go to repl.it and then start coding. And we'll put comments in so that other students who follow the video will know what we're doing. So we'll start off with a header comment that says, in this little file, we're going to measure how long it takes to call a function by copy versus reference using a very coarse clock, right? Coarse clock, time is a very coarse clock, isn't it? It only gives you a tick every second. Yeah. So if you want to go any finer than that, you can't use time unless we do some clever things like we're doing now, right? Which is like stacking up lots of them and then dividing. So But I think in 2C, yeah, I think around 2B or 2C, some of the code and quests you write, I'll also give back timing results saying that, this is how much the library version of the algorithm took. This is how long the reference version, that is my implementation, took, and this is how long your. So you just see these three numbers side by side, right? And then say, well, you know what? I got to shave off all these statements really, and then it'll be the same time as a library. Or yeah, it's fun at that point. But at that time, I don't do this clever trick, right? There is a facility which you'll find out by the time you're in 2B to count seconds more finely. I think it's nanoseconds. I think you may be able to count up to nanoseconds. So there's a clock variable or something. All right, anyway, but we don't need that for this, right? Because this task is not expensive and we can do it repeatedly. So we can just use a simple method. Come on, who wants to take the screen? Right, Soy was the one who went most recently. Jared took the screen yesterday, but if you want to go again, that's fine. Agnes, Madison, Maddie, Hiram, Alexander, anyone actually, right? Take the screen, open up an editor, and then
I can go. I think it's been a little bit.
So absolutely, then go for it, right? First one to go usually gets the screen. So take the screen, open an editor. No, actually, let's go to REPL. Oh, is it you do have a prompt. Hey, what is this? You got a Unix? This is Replete. Oh yes, it is replete.com.
Yeah, I opened it while when you.
Oh, you know what? It says replete.com. You know what? I used to think that it was REPL.it. Because I thought it was they bought this domain in Italy or something like that. But that's really cool. That's fantastic. All right, excellent. So on the right hand side, we actually have this command line, Unix command line. So you'll actually see how the system actually compiles this code. And I think one of the cool things here is that we should also be able to do turn off optimizations and things like that. Oh, it's actually using CLang++. So I think it's pretty much the same as G++. So, all right. So let's go right to the top of the source code file on line 1 and say this right on line 1 and put some comments there for future students who come browsing in this video. You can say, yeah, header comment. So yeah, let's try two kinds of comments in this code. So one of them is called a header block comment. Is that, yeah, like that, and then that's usually multiple lines, and you can put it in there, and you can say in this experiment we're going to measure measure the relative measure the relative difference in speed when calling a function by value versus calling it by reference. And then you can also say, we use a trick to measure extremely fast functions, which is to run them many times, run them 1,000 times and divide by 1,000. So that, by the time people go around to looking at the code, they'll also already know what it's going to do. That's like 100 million times easier to follow code usually. But when you know what it's going to do, you'll find that code. That's why it's a lot easier to follow your own code, right? Because you know what it does and what it's going to do or what it was supposed to do. Unless you come back to it like 10 years later and you've forgotten what it does. Okay, all right, so you got IO stream. Let's use namespace, that's fine. Okay, so now after namespace, let's define the first function here, right? So and now we can start our comment and say this function will take a vector passed by copy. Right, this function will take a vector passed by copy, and you can say void and call it something reasonable. Call by copy or something like that. I don't know. You call it whatever you want that indicates to you and others and future students that it's going to be. Yeah, const vector. Oh, obviously, so we need a vector include up there. So yeah, vector. Thanks. So vector int, and this is going to be passed by copy. So you can say space v, right? So it's being passed by copy, and then just return. And now it's cool because in this compiler, I hope we should be able to say don't optimize anything with -o, and we can be sure that the function will be called. Right? No. Let's do the other function also. So copy the whole thing and except change that copy to rough. Yeah, great. And now we have to get to the main part, which is going to time these functions. So let's say, and this stuff was going to be useful, right, for your midterm and all. So what we're going to do is have main spit out a TSV file, or we could be CSV, basically you print out numbers and then comma, we'll know. But it's harder for humans to read. So let's actually print out tab separated files. So, and then we can just suck it into Google Docs or Microsoft Excel or anything, right? So let's say, let's put a comment there saying, start a comment saying, to time the two functions above for vectors of sizes spanning 10 to 10 million, right? I think 10 million. That would be 10 million bytes times 4 is 40 million bytes. So that's 40 meg. So it would be the cost of copying 40 megabytes, right? 40 MB. Well, let's, I think, let's get it to a gigabyte. So 40 times, let's try, what did we say, 10 to, let's say 100 million, right? And we can always eyeball it later and, play it by ear and adjust the times. All right. Okay. So now we're going to start a for loop, and then for int size t. And here's what we're planning to do, right? So that you can also even suggest better ways of doing this. What we want to do is in our main, we're inside the loop for we're going to, the loop should basically go in, I think let's do exponential, right, for now, in steps of times 10. So it's going to 10, 100, 1,000, 10,000, and so on. So it's going to do it 8 times. 100 million is 8 times, right? 10 to the 8. So it's going to print 8 rows. But we don't want to say, from I to 0 to, well, maybe, let's say 8 now, right? Let's say 8. Let's say 8. Let's say size t I equals 0, I less than 8. Yeah, I plus plus. And we're going to refine this later, right? We can change this later. You can say upper limit and then use better looping structure, and that'll all be practice, right? Instead of saying, I'm going to increase by powers of 10, you could say I'm going to increase until the size of the vector is 100 million, and you can actually go from. Do you want to do it the other way? Because this is pretty standard, right? You want to do it the other way? So I'll show you, and you can tell me if this is useful for you. Okay. So you want to say for size t, and then instead of I, say vec underscore size equals no, not 0, right? Equals 10. So that's our first one, right? And then vec size is less than 100 million. I think was it 100 million? Or you could have a const up there saying max vec size, right? You can say max vec size, const int max vec size there, and size t max vec size, and you can say it's 100 times, 100 times 1,000 times 1,000. So that's 100 million. And because it's a const, let's make max vec size all uppercase, so that we'll know when we read the code, we know, right? Great. Now here, vec size less than max vec size, so max vec size instead of that thing, right? And then you want to say instead of I plus plus, we're going to say vec size equals, vec size. Type this, and you tell me if you understand this, okay? Because it's important, right? Vec size star equals 10, right? Now, all right, that's it. That is our loop. Unfortunately, why is it scrolling over? Is there something we can do to make this?
Sorry.
No. Oh, yeah, we can do that. No, but I'm actually thinking our code, what we're writing, maybe it's over 80 columns, And if it's over 80 columns, we should start thinking about, is there some clever stuff that we can do to rename variables to make it, vec size. We're going to be using that variable so many times that it doesn't make sense to have such a long, a long name for it. Let's not call it vec size. We could say size t n. Just say n, right? N equals 10, and then n. Yeah, okay, I think that's much better, right? Now, so that is our n, that is the vector size. Now, inside of here, inside the loop, you're going to say, and then this is going to have multiple statements in there. So we want a loop body, right? So yeah, all right. Now, we want to do two things here. We have n, which is the size of the vector. Now we have to create the vector, and we have to time the first function, time the second function, and print the timings. That's all. So you were thinking about essentially 5 statements in there inside of that loop, right? So the first step, we want to, what are we going to do? Create the vector, right? So you can say vector, vector int, and then you say my vac or something like that, or you can call it vac, vac because it's just here, right? No, and you can basically open parentheses. That's one way of doing this, right? Open parentheses, and you can say n comma 0. Let's fill them all with zeros, okay? I don't think it matters whether they're filled with zeros or filled with randoms. If you're passing by copy, whether it's zeros or randoms, it's going to copy them all over anyway.
Oh, cool.
Yeah. So, but that is something you shouldn't take my word for, right? After you've got the experiment running, you can basically play around with it and change it. Oh, well, does it actually change? Instead of 0, if I use a call to ran, right? And stuff the vector with randoms instead of zeros, is it different in timing, right? And you can verify that yourself. And then, and it will be a very important observation that many people even don't know, even professional programmers, right? They may know this if they think about it, but they don't know because they haven't done this experiment, right? If you ask them, they'll tell you the right answer because they're running it in their head and say, oh, well, this is what should happen. But I'm sure that very few people have actually done this and seen the output, right? So it'll be actually cool if you tell them that, I actually ran the experiment once, I got the answer, right? So so we create zeros and zeros. So we've created the vector. The second thing we want to do is time the first function, time the second function, and then print the values. That's all, right? So that's all we need to do, right? So we want to time the first function. How are we going to time the first function? Let's say actually, let's write this line, okay? Write this line saying, yeah, let's do a loop, actually. That's actually better and faster. So we'll keep the overhead minimal. It's going to be a few more lines of code, but that's okay with us, right? So let's say time, what's it called? Unsigned long, timestamp. Oh, now or then timestamp, unsigned long TS. Let's just call it timestamp. We can't call it then or now because that'll always keep changing, right? Now is suddenly then, and then is suddenly, right?
Is it unsigned long like UN64?
Yeah, you just call it unsigned space long. Unsigned space long. No, don't let it autocomplete.
Oh, okay.
Just don't let it autocomplete. Yeah.
Okay.
And then TS. That's for timestamp equals call time. And I believe you've passed it the value 0, right? Is that yes? If you pass it the value null, it is going to return the value of the clock, right?
Oh, okay.
Right. And that 0 is the same as null. And some people instead of 0, they say 0L because 0 long is the same length as a pointer. And time expects the parameter to be a pointer, and a pointer is 4 bytes. So you can't pass 2 bytes as an integer, and then the system will get all confused. So you can say 0L. Yeah, right, on most architectures. All right, so now what we want to do is call the first function 1,000 times, right? You make a comment saying call the first function 1,000 times. Yeah. And in fact, we can create another const up there saying num times, num times, and make it 1,000, so that if it doesn't work, we can just go and change it to 10,000.
Okay, should I do it up
here?
Yeah,
right there. Num times equals, I think let's start with 1,000 and then we can change it later. All right. Now, so for size t, j equals or I equals or n, you were using n already. So j or I, yeah, j less than num times j++, and on the next line, we're just going to call this function and pass it this vector, right? So call by copy, and then, yeah, vector, that's it. And then, immediately after that, take the timestamp again. Yeah, unsigned long diff equals, or yeah, and time, and you know, that's great, NTS. Yeah, NTS equals time 0 L, right? Now you've got the times. That's good. Once you've got the times, you can do other stuff, right? Measurements should, so now you can do other stuff. Yeah, start TS and NTS. Oh, then you have to change. Oh, something is missing here. And no, hang on. Oh, I see. You haven't done that yet. I see. I thought you were doing the. Yeah, with these glasses, the double equals looks like a minus sign. And no, but that's okay. Actually, hang on, just a sec. I can fit a bit more of you in here. Okay, and I can still see that it is. Yeah, not much worse. Yeah, go ahead. Now you can say diff. What do we want to do? Yeah, time per invocation, right? So you want to say flow double time per call, double time per call underscore, what is this? Copy, and time per call underscore copy equals, right? You want to do NTS minus start TS divided by you want to typecast. You want to put double in and typecast one of those to a double. Yeah.
Like, is it like this?
No, you have to put double within parentheses. Strangely enough, double without parentheses and num times with parentheses also works. In later versions of C++, they realize that, you know, double is a native type, but we can make it behave like an object, right? And so they said, you know, double also has a constructor. And so they said double and then, you know, value inside of parentheses. That also works, but only in later versions of C++. So let's not go down that road. So this is the, you know, the old way of doing that, which always is guaranteed to work. All right, now we want to do another chunk of code just like this for the other kind of function. And then finally, we can see out this the TSV line. In fact, I have an idea. Why don't you get the, you know, stick the time calls very tightly together with the for loop, and then we'll know that that's one chunk. You can have the vector declaration up there. Yeah. I think that's fantastic. Yeah, that looks much better. And then yeah, we want the same thing, same block one more time. Oh, I see. You can't have declaration a second time. Is everybody following along? I mean, it shouldn't just be me and Alex here just coding. I want to make sure that everybody's on the same page. Or let me actually see.
Yes.
Okay, all of you guys okay? Does anybody have any questions or doubts about what we're trying to do here? Because what we're trying to accomplish is, we need to be there, because it is simple and straightforward. Everybody needs to be on the same page as far as what we're trying to accomplish, right? How we're trying to accomplish it, you know, is the specifics of how Alexandria is coding it. That is a separate issue. But at the very least, we should all be on the same page as to what we're trying to do. Is that okay? Does anybody have problems with that? Fernando? Fernando, are you here? Jared? Okay, Jared has a thumbs up. Okay. I know Agnes is here. All right. Okay, good. Maybe Fernando's just stepped out, but remember to call out to him again. Is everybody okay with this now so far? Okay, so have you got it? Have you got? Thank you, Maddie. And all right, so let's go ahead and all right. So it's a for loop. So now time per call ref. Now we can do a cout after that. You can do a cout. First, you want to do n. And you know, shall we put a header line? Yeah, let's print a header line. Okay. So cout, and then within quotes, everything within quotes there. you say, what is it? N or size or whatever it is, because it's going to be part of the spreadsheet. You can say size, uppercase size, or, oh yeah, whatever it is, size, vector size. And then we want to have not a comma, you want to have /t for a tab, right?
Is it,
So
you mean max spec size or num times?
this is what you're going to put in, what you would have typed into your Google spreadsheet,
Okay.
or Excel spreadsheet, you know, as header for the row header.
Okay, got it.
It doesn't even have to be underscore and things like that, you know. No, not /n, right? Yeah, /t is tab,
Oh,
right? Yeah, /t is tab, /n new line, /r is carriage return. Actually, you know, we did a very interesting thing last quarter. Was it last quarter or two quarters ago? There was a student called Turkey, right? And he coded up something like you guys on screen using /r to create a visual effect. Use it on plain old TTYs, right? On ordinary consoles that are not fancy at all, just do characters. We coded up something that had a really cool special effect using the /r character. So we'll try that again. We'll try that again because maybe we'll have other ideas this quarter. It has to come after we do objects and things like that. So remind me if I've forgotten. All right, vector size /t. No, after the /t, we want to say ref function time, right? And then /t, ref call time. I think it should be ref call time, and then there should be copy call time. Yeah, copy call time. So that's our header. Now you can put your new line. Now you can put your /n or n-delta, right? So, all right, good. So let's now, this header needs to be outside of the for loop. Or else it's going to come out 8 times, right? So put that out, up there, outside of the for loop. That's, yeah, great. All right, so now we're going to do cout n, and then n, and then /t, and then the first time /t, second time /n. Great. I think that should do it, right? I mean, you want to return because is this main? Is this main? I think it's main because we're doing cout and all. Yeah. Okay, cool. That's great. What is it? Is it just indenting by 1 step or one? No, it is indenting by 2. Oh, because my screen is all squished up, you know, it looks to me like you're only indenting by 1 character, but it's actually 2. Yeah, okay. Yeah, you should be able to run it. Now, I think it should print 8 rows. It should print 8 rows and with that's taking a long time. So the 100 million is taking a long time. So what we can do now is we know, right? We know that it is taking a long time for 100 million. So was it 100 million? What is it? Is it done? Is it finished? Is that the end? No, it's running, right?
That's 10 million. So
yeah, so it's still doing 100 million. Right, and I bet it's going to take a long time. Maybe it's going to take 0.1 second. No, why is it taking? It shouldn't take this long for 100 million.
Did we do something wrong?
No.
Oh, is it this?
What is it?
N is less than or equal to, or no?
No. Wait a second. N less than max. Oh, it won't do 100 million. It'll only do up to a 10 million.
Oh, because of the n equals 10?
It starts at n equals 10, but it's never going to do 100 million, right? Because it's got to be less than 100 million. So 10 million is the maximum it's going to do. Yeah, but still, still I'm puzzled. I'm puzzled as to why the previous one did not terminate, right? After 10 million, it should have terminated, right? It didn't terminate. What's going on? So put it back to the way it was. Don't, get rid of the less than or, yeah. Why did it not terminate? N star equals 10, all right. Max size T. Oh, 100 million. 100 million is easy. 100 million should fit within a size T. So that's all okay. And comma 0. let's stick some Couts here just to to see, because this doesn't give us fine grained. If it was Xcode or VS Code, we can step through it one step at a time and find out where it's getting stuck. But because it's like a on online environment, we're going to stick some Cout. Just put a Cout right as soon as the vector has been allocated, saying vector allocated.
Okay, sure.
Right after, right after the vector has been allocated, I want to say done with vector allocation, and print the value of n there. Done with vector allocation, n equals. Now, I have a feeling that it's probably the allocation that's taking a long time. It's whatever machine they're running it on. Oh, it did done with allocation for 100. Is it 10 million?
I'm trying to scroll down, but I can't.
Okay, all right. Maybe it's doing the copy.
Yeah, no, you're
Maybe it's doing
right.
the copy, and it's getting stuck with the copy. Then is it?
Well, it never got to done with copy.
Oh, it did. Oh, I see. All right, swap the two around. Right, get the rough one to go first, and then the copy to go next.
Okay.
Right, and then
Oh, one second.
Oh, you want to comment? You want to comment? Just like, yeah. In fact, it'd be easier if you just make the unsigned long right at the top, and then
There.
it'll be the same. Yeah. Right after constant size t. Yeah, that's fine. That's fine. You can put them both on the same line. Start TS, comma, NTS.
Oh,
yeah. Comma, NTS, and then get rid of the next line. And I think, and then you don't need the decorations in here. Okay, that's a whole lot easier, simpler. Oh, and then double time per call ref. Oh, I see, double time per call copy. Okay. All right. I think that now we'll know where I'm pretty sure we should know now. Done with roughly. So the copy.
Stuff at the copy.
Copy is taking a huge amount of time. So here's what's going on that machine, which makes it look like it's going to be hard for us to test it on another machine over which we don't have control for this reason. It's a very subtle reason, I think, and it's my hypothesis at this point. But I don't know if it's going to be useful, but I will tell you. So here's what's going on. When for small amounts of memory, whatever machine they're running it on, no problems. Okay, it's giving it to you. But as soon as the memory request exceeds a certain threshold of, you're asking for 400 million bytes of contiguous space, right? Contiguous space, which it can give you. The memory manager kicks in on that machine at that point, and either it's just doing a whole lot of swapping, meaning I don't have that much memory. I got to swap a whole lot of inactive stuff into disk and then create some memory. So it's just like your garbage collector kicks in when you're running a Java program, right? So a function that should return instantly sometimes doesn't return instantly in Java because it's doing something, and all of a sudden the garbage collector woke up and said, okay, now is a good time to go and clean up, right? When you're not at least prepared for it. Okay, so like that. There you go. Why? You know what? It took a 0.079 seconds per call. Isn't it? It only took 0.079 seconds per call. That means n times. What is n times?
It's 1,000.
1,000, right? So it has taken. Oh, it has taken 79 seconds. Is it? Yeah, that's right. It has taken 79 seconds when you call that function with by a copy instead of calling by reference. Right? You see, if you call by reference, it's all instantaneous, bam, 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 like that. Now, however, because of this, we're not able to get a curve. So what we'll do is we know it's, we want to, 100,000 is too much. And I don't know if it's even the pager. It really may be the memory moving time, right? So, so what we'll do is not go to 100 million. Let's go to 25 million, okay? Let's go to 25 million. And then let's make the multiple smaller. So it'll still be exponential, right? But it won't be like in steps of 10. So let's go in multiples of 5. Let's go in multiples of 5 up to 25 million, right? I think we'll get a decent number of rows. this time, and we'll also get a parabola shape. Not a parabola, you'll see the divergence very clearly, and get rid of all the comments. No, you got a lot of comments in there.
Okay.
Done with and all, right?
Yeah.
So let's get rid of the comments. Just put a comment, yeah, comment in front of the comments, or the you know, tags, the annotations.
Just
Right. Okay, cool.
searched it up.
Right. So, oh yeah, there you go. All right. Excellent, excellent. Okay, now this you should be able to just copy and paste into a Google spreadsheet, right? Or an Excel spreadsheet if you have Excel handy, right? You should just, and then it'll ask you, how do I interpret the separators? You can say they are tabs, right? And then it'll just import them in the right columns. You can select the columns and then ask it to plot a graph. And you'll see one of those graphs is like a line, right? It actually starts going higher and higher, right? 0, 0.01, 0.00, you know, so 1 second, 6 seconds. I bet the next one is going to be like 25 seconds. I don't know, right? So it's going to be increasing steadily. Calling by copy or calling by reference is constant like that. Okay, so and that is, I think this is a very valuable class, right? Because it very clearly tells us or demonstrates to us the value of not passing by value. That's kind of strange to say, right? The value of passing by reference, right? When you pass by reference, everything is so cheap, right? But not just knowing the value of passing by reference, you know, is not going to make us great programmers. We also need to know the cost of passing by reference, and the cost of passing by reference is that now that object is now accessible to that other person, and they could change it. And so C++ gives us double protection, saying you can pass by reference, enjoy the benefit of passing by reference, but make it, you know, cons, so that the compiler can make sure the other person cannot mess with the object. Does that make sense?
Yes.
Yeah. All right. So this is kind of cool, isn't it? See, so what is it? What is it? 3 million? Is it 3 million?
Yeah, it's at 3.
That's strange, because 10 million last time only took 1 second, right? 0.001. Last time, if I remember correctly, 10 million took 1 second, and then 100 million took 79 seconds. Right? Now we have like it's less than a million. So I don't know, their clock is all screwed up, or they're running it on different machines, right? Maybe they have a bunch of maybe they're not a professional setup, like having identical racks of identical machines. Maybe they're a homegrown thing with, you know, a PCXT here and, you know, hooked up to a homegrown cloud service serving Replete, right? So maybe this program got shunted to a.
I think you have to upgrade in order to get unlimited space and the same machine.
No, that is for space. I'm pretty sure that these sites give you compilation for free, but then if you want to store the thing, 16 seconds. Yeah, I think if you want to store it, they tell you can store it here for money. I don't know what is the motivation behind many of these things, because, you know, as programmers, we'll all find eventually that, you know, it is quite dangerous to save things in many places, right? You forget, and it takes more work for you to remember what is, right? So so if you're going to be cutting code, you want to store it in some place that, you know, where everything is, every other thing that you have is, so that, you know, you have one place to go to. So that's a danger, right? Even as students, if you start saving your code in these places, you may not even remember, right? So on the other hand, if you stored it and shared it on not even our thing, right? If you shared it on Stack Overflow or some of these well-established places, they'll always be there, right? Even many years later, you can go and refer to them. But this, I think, was a cool experiment. Does anybody want to copy that, put it into a spreadsheet, and see if we can graph it? We only got like 3 points. Well, and in fact, many of them are going to be 0. So I think we should probably start at 15 million. But, you know, it's not reliable. But we can run the same code now in online GDB. Maybe they have a better machine. No, I think you have to do a special paste or something, and it'll tell you something, right? So you have to do a special paste, maybe. I think it's Command-Shift-P, maybe. Oh, is it? I don't know. Oh, you know what? You can paste it all into a column, and then you can ask the spreadsheet to split the column up for you. Yeah, paste it into the same column. Yeah. Now you can select column A, and then you can ask it to split it into 3 columns. No? I don't know. There was a way in which you can put everything in one column and then it'll split it up into 3. But anyway, these numbers are not reliable, we found, right? I mean, maybe they're reliable, but we only got 3 points. What we need is more. But we know one of the lines, the called by ref is going to be all zeros, no matter how big the vector is. And the call by ref, in fact, you can go vector sizes all the way up to 4 billion. No, maybe you can do 4 billion, right? 4 billion is 16 billion. That's 16 gigabytes, and that machine probably doesn't have 16 gigabytes, right? But if you can get more data points. You can absolutely get more data points and start higher too, and then you'll see that a call by ref is a flat line, and then this actually should be a straight line. It should be a straight line, or something weird is going on. Okay, because the only cost should be the cost of copying memory over. So essentially 2 times the cost, I think, of the memory move instruction. Right? If you look at the Intel specs, it'll tell you how many machine cycles a mem move will take or something like that, right? So you can actually calculate. You can calculate, exactly how long that vector copy is going to take back and forth. And then you can say, well, that is how long the memory moves actually took. So the rest of the time, if it's like we came up to 0.077 seconds and the actual time was 0.079 seconds, then the 0.002 seconds, what the exact overhead is, right? And then you can also do other crazy experiments, right? You say, if my machine is really hot, this extra overhead is more, right? So you can create temperature profiles. This is how all these things are done, right? So you keep everything constant, and then you can generate a profile for one parameter. And then you can say, well, if this changes, this is how this parameter changes. That's how we come up with all these, data centers that need to be kept at a certain temperature for optimum performance and things like that. And all right, cool. That's great. Well, this is not going to do anything meaningful for us. I think we only have 3 points. But you can, if you want, run it. Yeah, you can try. You guys can. You guys want to take some time and play with this program and create more data points and play with it? Yeah, I'll be around. You can play with different kinds of for loops. Generate different kinds of data. Yeah, like usual, the usual class. What time is it now? Yeah, it's 9 o'clock. Do you guys want time to play on your own, like a half hour or something with this code? And if you have questions, you can call me, right? I'm just going to be here.
Could we also look at the code from last class?
Yeah, sure. All right, bring it up. I can look at it. I thought we didn't have any.
I can let someone else take the screen when we switch to that.
Yeah, I'm sorry. I thought we didn't have any code from last class. Usually we do refactoring of Tuesday code. Yeah, I forgot.
Yeah, but we didn't finish on Tuesday.
Oh yeah. Okay, let's finish it.
Okay. Does someone else want to take over? And it's on Reddit.
Oh, it's on Reddit. Okay, cool. Yeah, someone should take over, right? Because Alex has been driving so far. Why doesn't someone take the screen?
I can take the screen.
Okay, Hiram, go ahead.
Stop.
Okay.
Oh, stop there.
Daddy sleepy. All right. All right. It's okay. And then daylight savings should kick in. What is it? Is it next week? Next weekend, right? Daylight savings will disappear. I think it's the first week of November. So wow, okay. So yeah, Maddie, you got to gear up then, because next week this time it may be dark even. No, not dark because the sun's out.
Oh gosh.
Yeah, but what is no, actually, fall back. Oh yeah, okay. So despite so many years of being in the US, I still haven't figured out whether clocks are going to be fall back. So what is 8 a.m. Will become 7 a.m. So you actually get 1 extra hour. Yes.
Did you mean for me to share the screen, or Hiram?
Whoever was going to pick up the screen. I thought it was Hiram. So yeah,
okay.
yes, yeah, Lei, you can go.
Okay.
Right? You were absent last class.
Yeah, but I have the code.
Yeah, go ahead. You can take the screen. Yeah, I think Hiram also went recently, so you can go now.
Yeah, I was the one that wrote that initially. I never got to finish it, which is
so. But yeah, so yeah, you guys, Alex and Hiram can stick around and guide Lei, right? When we do these things. All right, what are we doing here? Count letters. Bam. Okay, so that's fine. Okay, you're counting. Yeah, that looks good to me. And what are you doing? Yeah.
So
Okay.
We were gonna sort.
Yeah.
Oh, I see. You wanted to sort it. Okay. Do you want to sort it? Do you want to do a counting sort?
Yep. I guess.
Yeah, okay, all right.
I should
All right, so
probably
in that
say
case,
something.
we want to have a real document. How about this? Okay, can you copy this code into that replete thing so that we get that window, like the Linux or whatever that window is? Okay, and then we'll get main this program that you're writing to actually work on pp.txt, which is what Hiram had.
Yeah.
Right? Hiram had pp.txt. We'll download it again from Gutenberg, maybe on that other machine. Can you open a tab and go to replete?
Yeah, really quick. I just really hope that I copied it correctly because
It's okay. We can write it again. Don't worry. Why does it ask you to log in? You should be able to just do it, right? You can unshare if you want until after you've logged in, and then you
I
can.
logged in with Google. Wesley, I have logged in with Google. It might be fast.
Okay.
Oh, I see. Okay. But but then they'll give you a some questionnaire, not questionnaire. You got to check what information you're okay with Google sharing with that site, and it'll take you time. Right?
It didn't pop up for me. Maybe I've already been there.
You just say, hey, yeah, okay, all right, cool.
Yeah, like you were saying, and I forgot.
So what are we trying to do here? All right, so what we want to do is great. Put it there. Now let's see if wget works from the terminal here, right? If it doesn't work, I'm afraid we'll have to go back to Hiram at his Linux machine. All right, late, but let's try type wget and hit return. Wget and hit return, because maybe they haven't made oh wow, okay, type curl, type curl, enter. Okay, all right, okay, so type this. we'll download this pp.txt on their machine, okay? And so we don't have to get it from Hiram, right? So type curl space. Let me try and remember. Okay, it was an interesting number, right? So https:// I think it was Gutenberg.org. I think it was /files. And then it was the first, some permutation of the first four numbers, but not in order. So it's not 1, 2, 3, 4. I think it was 1, 3, 4, 2, right? If not 1, 3, 4, 2, we'll try 1, 3, 2, 4, right? I think it's 1, 3, 4, 2, right? No, don't. No, 1, 3, 4, 2 slash 1, 3, 4, 2 -0.txt. Yeah, all right. If it doesn't work, let's try 1, 3, 2, 4, okay? No, it didn't? Not found. Right, try 1, 3, 2, 4. No, you didn't change the other one.
I accidentally hit the down arrow.
It's okay. Now that looks okay. Hit return. You're still not getting it? Wow. Can someone tell me what the URL is? What was the URL that we used before? One more time, up arrow again. I want to see what we used. Okay, Gutenberg.org/file/. I think it was 1432. Try 1432. All right, so someone go to Gutenberg.org and look for the URL for Pride and Prejudice. Yeah, you can do that. Yeah, Gutenberg.org. I think it was under popular 100, the popular top 100 or something. No, why is it?
Did I spell Gutenberg?
Oh, ERG, I think. ERG, Gutenberg.
Oh, that might explain it. Okay.
Oh, even the other one was good. Oh, maybe that's what it was. Maybe, up arrow all the way. No, it was one. Try the first one I said. 1, 3.
Okay.
Oh, it is. It is it?
It looks like it, yeah.
No. I don't know. Maybe not that. Up arrow. I want to see what you type.
Oh. So change it to what?
Oh, is it 1, 3, 4, 2? Well, it doesn't matter. Whatever it is, it doesn't have to be pp.txt, right? So just go to the end of the line and then greater than into /tmp/ junk.txt, right? /tmp/junk.txt. Oh, all right. You want to put it right here? Okay. Yeah, they're going to delete this directory anyway when you're done. All right, yeah, that's fine.
Okay. Okay.
Yeah, they just created a, yeah. All right, so that's fine. You can put it there. Well, I hope this is not a huge file, okay? Because pp.txt was 700. Yeah, all right, good. It's only 314 kilobytes. That's good. All right. So it is not Pride and Prejudice, by the way. If you do a more, and then junk.txt, we'll see what's in this file. Just out of curiosity, just do type more. Yeah, junk.txt, tab should autocomplete here. All right, enter.
Okay.
All right, what is this? What is it? Start of the project. Further down. Oh, Serafita. What is it, Serafita? Is that the name of the book?
Yeah.
All right. So I hope it's an English book, right? It doesn't matter. It's got English characters in it. That's all we need. Yes?
Yeah.
Great. So hit Q and get out of this. All right. Now we get, this is the command we did last time, right? Let's try this again. WC. That's word count. Space, junk, J, and then tab, J tab. All right, enter. All right, so this file has only 5,600 lines in it. That's okay, right? And it has 321,627 characters. No, that many characters, yeah, and 54K words. Okay, all right. Now what we want to do is your program should read this file, right? So what we'll do is make your program read standard output, or standard input, like CN, right? So what we're going to do here is, where you go? Where we got? Okay, let's take a look at vector. Let's do a couple of things here, okay? The count letters thing, take that vector of int counts and move that to main, right? Let's take that vector of int counts, yeah, take that and triple click on the line. No, yeah.
All right.
That's fine. Just paste it there. Okay, indented in properly. All right, okay. Now, count letters, what we want to do is, let's change the name of that to, yeah, let's call it count letters, but say count letters in, one is a standard input. Yeah, okay. Count letters in stream, right? Call it count letters in stream, right? Call it count letters in stream. Not there. Oh yeah, there too. And then it's not going to return a vector of int, right? Here's what it's going to do, right? It is just going to return a size t right there. Just make it return a size t instead of vector int right there on top. Line 6. I'm pointing my finger. Obviously, you can see where I'm pointing, right? So I'm pointing at the line of code that you need to edit. Okay. No, it's just size t, not vector of size t.
Oh, okay.
Right? So and it's going to take two parameters, right? The first parameter is going to be a stream. So let's call it iStream, right? iStream instead of iStream. Yeah, and not const string and so on. Okay, no, iStream, iStream. No string there. The type is called iStream, right? And that is a type of things like CN, right? iStream and then ampersand, because we're going to pass it by reference. is. Yes, that's a variable name. We're choosing a variable called is to stand for input stream. Okay, comma, and then we're going to pass it a vector of counts by reference. Okay, so we're going to say vector of size t, space, ampersand counts.
Do we need this?
Yeah, get rid of all of that. No const even, right? Why is it wrapping over? Are we over 80 columns there somewhere? Yeah, maybe our name of the function name is too long. Count letters, just call it count letters because we know what it means, right? And then we could put a comment on top of that saying this is going to count the characters in the input stream, in the supplied input stream. Yeah. And put the result in the vector by reference. And put the result in the vector passed by reference. Indexed by ASCII value of the character. Indexed by ASCII values of each character. Yeah. All right, good. So all right, good. So this, what does this function have to do? So what this function has to do is basically keep on reading lines from the standard input, or you can even do while, go right to the top and say char C, character C, because it's all buffered. You can read it character by character too. No extra cost here, right? So semicolon and enter, right? Enter. Now you can say while. Let's have a blank line after the char C. Yeah. Now you say while is double greater than right shift, right? Is double right shift into C. On the next line, we want to say counts of C plus plus.
Oh.
Right? That's all. You can get rid of the
Is the
braces and
plus
all.
plus
It's just
inside?
one line, right? You get rid of the braces and everything.
Oh, okay.
Yeah. And then we're returning a size T. What makes sense to you? You don't need the for loop. By the way, this is a refactored version of what you guys already wrote, right? So you know two different ways of doing it. So we're doing it in a slightly different way. Now, what makes sense to return? Because here we are returning something, right? We have the ability to return a value. In addition to the vector that we're filling in, we also have the ability to return a value. So if it makes sense to return something, while I ask,
Maybe just 0.
yeah, just say no. In fact, make it void for now. When we figure out what it needs to return, if we can figure out if it makes sense to return something, yeah, just and make the size T a void right at the top,
Okay.
Not there, yeah, there, right? And then get rid of all the blank lines and tidy up this function. That's our function, right? Tidy up this function. Yeah, okay, all right. So that's basically it. And I think that should do it. So when you call this, so all right. So in your main, what we want to do is basically count all the characters in standard input. So what we'll do simply here is that you can be, yeah, we're just going to call count. What do we call it? Count letters? Yeah, we're just going to call count letters, right? And pass it cin as a parameter. Count letters and the vector as a parameter. Cin, comma, I think counts. Yeah. So when this function returns, counts should be filled in with every ASCII value that you saw should have a corresponding number that's been incremented. Yes or no? Is everybody okay with this? Yeah. So let's just print it out. Let's dump it out first to see if we get the counts, and then we can think about how to sort it. Yeah. Is everybody okay with that?
Oh,
What does it say?
Oh, it's misspelled.
I think you got 3 T's somewhere.
oh, yeah.
Why is it still underlined? No, it's still underlined.
No matching function.
No, it's yeah, count underscore letters, count underscore. Oh, maybe cin. I stream. Maybe it maybe cin is not of type I stream, right? Change that to IF stream instead of I stream. Just change it to IF
It
stream.
also says vector hints when we set it to take.
No, okay, all right.
Size.
But I don't think that's a problem though. But let's run it now. Run it now. I think we may need to change that to. All right, maybe it compiled. That was a problem, was it?
That was a problem. I don't know.
Okay, good. It's running now. It's compiled and running. That's great. Control C. Now, does anybody have any guess as to why it ran, but it's just hanging?
It's waiting.
Yeah, it's waiting for, because we set it up to read standard input, right? We set it up to read CN, right? And we didn't print a prompt saying, oh, enter your text now. So it's basically waiting, and it's a really bad design, but we know it's bad design and we're still doing it because we just want to run an experiment. But you can print in, print all the tags and annotations later. So what we want to do now is do this. Where do you type the file? Junk.txt. Is it here?
Junk.txt.
Here, you have it in the current directory? Cat.
Yeah.
Okay, all right, yeah. Okay, so now you can do cat junk.txt, cat junk.txt. Now, if you don't hit return. If you hit return, it's going to dump the contents on standard input, on cout, right? In fact, hit return, it's going to dump the contents of junk.txt. Yes?
Right.
Now, we don't want it to dump it here. We want it to dump it into main, because main is waiting for input. Yes? Main is waiting for input. So the way to do that is hit up arrow. Now go space, and vertical bar. That's a pipe symbol, right? Now what that says is that take the output of junk that command cat txt, right, which came out on screen before, take that output and then connect it with a pipe to the input of main, because main, when I run main, it's going to ask for input. So connect the two, so this output goes to that input. Is everybody clear on that? This is totally irrelevant to CS2A. Right? Because you don't need this for CS2A. This is like Unix and Linux and things like that, and not part of any of our courses, I think. Or maybe it is, you know, if you do, I think if you do Mike's courses on Linux, he'll probably teach you these things. But I think it's useful because it shows you, you know, how to write a program that will read standard input. And then you can make sure that it works by just piping it in, right? You can generate lots of, so type in main.txt, main, right? Is it /main, yeah, I think that, right. Now it should basically, what are we doing? What are we, oh, we aren't doing anything in main yet. Well, right now it's going to count all the letters and it's going to print hash a colon and the first count, right? It's probably not going to do anything. It's just going to print hash a colon, right? Hit enter.
Oh.
Yeah, because that's the only thing main is doing right now. Yes. Right, so we can go to main and change it so that it dumps all of the counts. So go to main and say now, get rid of that line 24, and we'll say put a comment there on line 24 and say print out the frequencies of all of the uppercase English letters. Print out the counts. You know, counts makes more sense, right? Print out the counts of all of the uppercase English letters. Oh, you've done that? Uppercase English, not count letters, uppercase English letters in the input text. Uppercase English letters in the input text. Next line, you can go to the next line, yeah. It's wrapping over, I think. So you can break the line and go to the next line. The 2-line comment is fine. Right, now you want to have a for loop there that says for, this is a char C equals uppercase A within single quotes. Now anything, anything here that is confusing, you guys have to ask. If we're using new syntax that you've not seen before, right? Because there are some concepts embedded here, and we can talk about those, right?
This is pretty cool. It's pretty cool.
Oh, you mean this for loop?
Yeah.
Yeah. And we can basically exploit the fact that the letters in English are in contiguous locations, right? If they were scattered all over, you can't do this trick. That's why. So you can say for char C equals A, C is less than or equal to uppercase Z. Uppercase Z in Z, yeah, and then C++. Now every time char is incremented, you'll see A, B, C, D, and so on, right? Yeah. Okay. Now you can say C out, and then the character itself. You can say C, and then left shift again, and then a colon within quotes, yeah, colon space also, so that you don't, and put a space before the colon too, because the letter will run into the colon otherwise, yeah. And then counts of C. No, you got to say left shift.
Right.
Is everybody okay? Everybody on the same page? Yeah, Soe, good. So your screen is like angled so badly that only half your face is visible. Well, you don't have to, you don't have to sit up like that. Change your screen angle so that it's better. It's a desktop, is it? If you want a desktop, you should be able to change the screen angle. Yeah, that's much better. End line. So if you run it now, you should be able to see the frequencies of all of just the uppercase letters, because we didn't fold the lower and uppercase together. Yes.
Oh, I didn't.
No, pipe it. Yeah, Control C. Yeah, up arrow 2 times.
Oh, it clears it every time I click the run button.
No, don't click the run button.
Right.
Oh, I see. You had to compile it. All right. Now you can say up arrow 2 times. I'm sure you have it in your. Yeah, that's fine. Practice for typing. There you go. So in that text, you have 384 A's, 251 B's, and so on and so forth, right? And this is, you don't have the lowercase letters, right? And, it's an exercise for you, how to get numbers, lowercase letters, and uppercase letters, fold them all together, maybe. You can try all these tricks. Now, if you want to sort it, we can do a basic counting sort, right? Now, we know, here's a funny thing, right? We know, and it's a trick, and I don't know if this is a trick, right? And what is the size of this file? 300K, 350K, right?
I don't remember.
Whatever it is, you do an ls-l of jump.txt. 300K, right?
Yeah.
Right around that. So we know that no character in this text is ever going to occur 500,000 times. Yes or no? Yes? Okay, good. All right. So which means that really sets us up for a constant time sorting algorithm, which is so really cool, isn't it? It's not even a log linear algorithm, it's a constant time. So sorting things in constant time is actually, you can't do it unless you have very specific domain knowledge like we do now. In this case, we have domain knowledge about this very specific problem, which says that no item is ever going to occur more than 500,000 times.
Why does that make it linear?
Right, I'll show you. Right now we'll do something and it'll be linear. Okay. So in your main, go to your main. All right, go to your main, and you're going to say on the next line before the return, right? You're going to say int frequencies of size t frequencies of 500,000. No, I'm sorry. Size t, vector of size t frequencies, and you have 500,000 of those guys, right? A vector of size t, and then frequencies, right? And then you and you have 500,000 zeros in there. So you say 500,000 and then 0. 500 times 1,000, easier to read, and comma 0. Yeah. In fact, it doesn't even have to be 500,000, right? Because if you have a limit on the maximum number of times any character can occur, like 10,000, you can say, I'm going to stick with a vector of size 10,000, right? And actually, it's also possible to write a safe program, even though a character may occur more than 10,000 times, right? And those are things, and constant time too, linear time. Did I say linear time or constant time before? Sorting and linear time.
Oh, you said constant time.
Oh, I'm so sorry. I'm totally wrong there. Yeah, I said linear. I should have said linear time, right? Not constant time. I'm sorry, Alex. Thanks for picking it up, right? So it's sorting in linear time, which is like a huge challenge, right? Many times you need domain knowledge to do that. All right. So here, now probably everybody knows how to do it. So what we want to do is for size, what is it?
Did he freeze?
We want to do, so what we want to do is the number, what are the frequencies, right? Just, scroll up on in the black part of the screen there, scroll up, we want to look at the number, right? Look for A, right? 304, right? So
384.
384.
Yeah.
So the counting sort should basically have geez. You count each character, and then you want to pick the maximum. I'm going to have to think about this now. Well, you have the frequencies and you can sort it. Well, you can only do a log linear sort right now. We can do a linear sort, okay? Let me get back to you on this with the domain knowledge. This is curious and curiouser, right? That's what I did in curious. Think about that. But in the meanwhile, why don't you guys do a linear sort, log linear sort with standard colon sort, and then print it out, right? Give me 5 minutes to think about how to do this with the counting sort, and then I'll get back to you. All right. So I'm just going to be sitting here. If you want, I can mute myself while I think, right? But I'm not going to be saying anything. You guys can feel free to talk amongst yourself, okay? During that time. It'll only take me about 5 minutes. I'm just going to be here, okay?
What is a linear sort?
So when you, so I don't know what a counting sort is. It's not one of the like standard sorting algorithms you learn. But generally, so linear means as the size of what you're sorting increases, it'll increase like with a slope.
Oh, okay.
Like,
but it's
so
not
like
an actual like do this and then do that to sort.
No, like the speed will increase with the slope. So if you have one for loop, you're like doing one thing per element, so it's linear. So it's
Um,
confusing to me because we learn in school that like the best you can do is like n log n, which is what he was saying the standard dot sort does, but n log n is slower than just n.
Yeah.
Yeah, that's my best TLDR.
You know,
and
even if I don't even if I don't remember this in class, you know, I will post in Reddit that the solution that we did before in class, which was basically just to count, and it was linear, not log linear. And you can do linear if you have domain knowledge. And Alex is absolutely right, right? If you don't have domain knowledge, general purpose sort is log linear, right? So you have a bound. But if you do have domain knowledge, you can actually bring it down to linear. And you know, the counting sort is one of those. Just give me a couple more minutes, right? And let me think through this a bit more for this case anyway.
So I think we can just do a like standard sort, like std : sort. I think that's good instead of a for loop.
so what do
No, I guess not. I don't know. I'll Google it.
wait, is this, do I just put the vector in this?
Yeah, I guess so. Frequency.
Okay, or it's counts.
Oh, it's counts.
Yeah.
And maybe
And,
get rid of the standard : That was wrong.
just one colon?
No, just get rid of standard : I
Why
think
don't
you
we
only
sort
need
it?
that if you're in a different namespace. So
Oh, okay.
yeah. And then maybe we should print out the
Yeah.
what's in there.
We're sorting all the words.
We're
The
sorting
frequencies.
the frequencies of the characters.
Got it. Okay, so the
Oh.
characters will be sorted. Okay, that makes
Yeah,
sense.
we're sorting the characters.
So the thing that is interesting is, will we be able to tell which letter the one that we sorted corresponds to still?
No, we will not. I think.
Yeah, that's what I thought. So that'll be a different
Oh,
problem.
yeah, you're right. Yeah.
Because currently we're referring to it by index, and that's changing.
Yeah.
Oh,
The
okay,
best
yeah.
I-
So that's where I was confused. I was like, what are you?
So then I guess
If you just want to know,
A plus the index would be the letter. Right. No, but it's sorted. So
Yeah, so we're just sorting the numbers, not the letters.
Yeah.
That's great.
I guess this is where stuff like hash tables is useful.
Yeah, like I have an idea, but it's really bad. I don't know. Yeah, so I don't know. So like my idea was to have another vector with like 0 through like 255 or something, or 0 through 20. And then it's like 1, 2, 3, 4, 5. And then as you sort one, you also sort the second one like the exact same way. So that's a bad idea.
How do I but you can't tell what goes on in this, right?
And it's red highlighted, which is always
That's
weird.
That's right.
Anyone wanna like do our own sort while we wait?
It's
Oh,
not.
okay.
It's I don't. It's finding the mode that was in linear time. I remember now. It's not sorting the whole thing, but I had an idea for extending that curious quest to sorting, but maybe it wasn't linear. It is certainly an interesting problem, guys. You should continue talking just like you're talking now, trying to improve the time it takes to sort it. Oh, I see you're just using a regular sort to sort the counts. But if you do it that way, you'll lose the
letters
index,
Yeah.
for the letter. So, so this way you only get the letter frequencies. But in order to get sorted,
Right.
you have to write a special routine here, which will also preserve. The challenge here is that the way the data is being stored is in two different ways, whether we realize it or not. Many people don't realize it. One of them is explicitly, the count is explicitly stored, but the character is not explicitly stored anywhere. It is not stored as the value of a cell. If the character is being stored as the index of a cell. Yes?
Right.
And that is the problem. So that's why when you get to copying it over to another place, you have, so the only way you can get the whole thing over is to create a new object that contains both the index and its count and carry them both together.
Mhm.
And that is the reason why sorting this is a problem. Obviously, you can find the mode, right? You can easily find in constant time the letter that occurs the most number of times. Actually, that is the problem we should have started with.
That sounds
Right.
fun.
Yeah, so that you can find in constant time, not constant time, linear time, right? In the size of the vector, right? Because otherwise, how would you do it? For each letter, you have to maintain a hash table or some counter, and you have to keep this. So this way, you can do it with the counting sort, and you just have to scan this one time, and you know exactly which letter occurs most, right? But sorting is obviously going to take, that summed over, it'll be log linear. Yes, so I think I was mistaken there. But if I do come up with an interesting sorting problem that uses counting sort, counting sort maybe goes by another name called bucket sort or something like that. Yeah, it's not part of our syllabus, but those are many different hacks of sorts. I call them hacks of sorts because they're not general purpose sorting algorithms. Right? It's sorting algorithms that exploit specific domain dependent data. Right? If you know the bounds of the data, you can do a slightly different sort. Right? And so on and so forth. That's the reason. But I'm trying to continue to think about that, see if I can come up with something. It's not going to be on a midterm, but I'll see if I can frame it into something we can work on during the second half of this course. I'm pretty sure we'll do at least one sorting problem, right? But it'll be generic sorts towards the end of the quarter, week 7, week 8 maybe. When you start to implement binary search, we'll also introduce sorting, right? Because they're very closely related to each other. But that's all I can think of right now, because otherwise, yeah, I think it was the reason I got confused before was because it was the mode finding problem, and finding the mode. If you don't do it, mode is the most frequent thing, right? In data, the mode of the data is the element that occurs the most number of times. And how do you find the mode in a large number of integers? I think that was a problem. It was only a year since we created that question. I've forgotten already. So yeah, a large number of integers, and you got to find the mode in linear time. I think that was the name of the quest is Curiouser and Curiouser. Right, you can type it into the system and give it a go if you want. It's called Curiouser and Curiouser. And a couple of students actually solved it and got the prize. I think I gave them $150. So yeah, try it out. And it's just finding the mode. And for some reason, I thought it was sorting. I went and took a look. How the hell did I do it in Curiouser? And then found it was just finding the mode. So not a very exciting result to come back to you guys with, but certainly that's what happened. Is this okay? I mean, are you all? Is this what you wanted to do with the code? You've got and obviously we found that in order to find the most frequent letter, you got to scan this list one more time. right? From 0 to, or from A to Z, and find out which one's got the highest count. And that is the highest, right? And, that's all. But to sort it is a different game. And let's not go down that path right now. We will absolutely do it in week 7. And I'll try and pick up a couple of interesting problems involving sorting, involving non-traditional sorting, right? Not the ones that we learn in a book, but the ones that we're going to try and experiment with domain knowledge and find out it actually works better. And then that will help us develop a good intuition about sorting. Because sorting is one of the archetypical computer science problems, if you think about it, right? It's really bounded. You have to examine every pair of elements, really, unless you come up with clever ways of not having to do that. Otherwise, you have to examine every pair of elements. And we've already found that the total number of pairs of elements is related to the square of the size of the set, right? If you have n elements, then you have n squared minus n over 2 pairs. So it's going to grow as a square. And in fact, if you open a tab and go to Desmos, you can basically plot x squared and x, and you can see the 2 curves, right? It'll be a parabola and it'll intersect the line at some point, but after it intersects, it's going to go much faster. And that's all there is to it. Was this exercise useful? You know, counting the frequencies, and I think, you know, vector of frequencies. I know I don't think that's going to. You can erase that line. Is it late handling the code? Yeah. Line 29. I don't think we're going to go down that road now, because I was thinking that we'll try and sort it, but I have to think more about that.
Yeah.
But this essentially accomplishes most of what you guys set out to do, I think, except for the sorting. I don't know if sorting was part of what we decided to do, but this is essentially it. If you want to count the characters in a file instead of standard in, all you have to do is, I can show you, right? For that, I need to, it's called junk, right? We'll just hard code the name of the file junk. Are you guys okay? Do you want to know how to read a file in here, right? Instead of standard input? All right, we'll just hard code the name junk, but I can show you how to use any file that you specify on the command line, right? So up after string script equal, we don't script anymore, right? So instead of string script, type if stream input file stream. Open parentheses. No, space. Call it IFS, and then open parentheses and junk.txt within quotes. Right? And so when you count letters, instead of cin, pass IFS, that's it. All right, now you don't have to invoke your main in that funky way, saying cat and pipes to main. You just run main, it'll give you that number, give you that list. You can just run it. No, it's only printing 3 or 4. What's going on? Oh, you have to include fstream at the top. There you go. Right, it compiled and ran. It's exactly the same. It's reading a file instead of standard input. So Unix programmers, right, traditional Unix programmers, and it's a very good practice, tend to do is that they look at the command line, and if there are parameters given, they'll assume that's a file and read it. If there are no parameters given on the command line, then they'll read standard input, that's CN, right? So you can have one program that does both. It can read standard input piped in if nothing is given to it on the command line, but if something is given on the command line, it won't read standard input to read the file. So you can do that using an if statement here, right? So I'm not going to do that. I don't even want to leave that as an exercise for you guys, because it's all pretty straightforward using if and standard control structures. But that's essentially all there is to it. We've written another program today. Well, basically you guys wrote it last class. We hacked it up and had another version of it. And the control structures we're using here. Also brush up on do while loop, right? Although we don't tend to use it a lot, look at do while loop and also look at the difference between I++ and ++I. And if you're ever in doubt, just run the code in your head. And in the odd case, like 3 or 4 questions, you will have the luxury of actually running it in the browser, all right, on cpp.sh and finding the answer. Or if I use plus, it's got to be 6, not 7, right? So you can check those things out. You won't have time to do it for every question, but you can certainly try it out for the odd question. Does that answer all of your questions? Are you guys feeling confident enough about the material so far for the midterm?
Yes.
Yeah, I think many of you are already programmers in other languages anyway, so you can bring a lot of that to bear, because learning one language after learning another language is usually easier, right? It's usually getting the first language down that is hard. That is getting the programming mindset, and that's the hard bit. Once you get that, that's why, someone asked some quarters ago, some student asked, oh, this boot camp costs like $50,000, $20,000. Should I go to this boot camp and learn? Because they promise that you can learn this language in like 30 days, right? But that's not how long it takes. It takes like years for the first language. It does cost $30,000. It does cost a lot of money, but it's not targeted at first-time learners, right? It is targeted at people who have already been there, mastered a language, and and thereby also made lots of money, right? So that's why it's all $30,000, $20,000. Because if you've been programming for any decent amount of time, this is not big money for you, right? So you say, well, okay, well, I want to go and learn Go, all right? I want to learn some other language. It's just come out. And since I already know this language, it's not going to take me a great deal of time. So essential bits, I want to, what is the benefit of passing by continuation style here, right? And we'll have experts there during this boot camp to answer. That's worth $20,000, right? But if you're going there, I want to go and learn how to use a for loop and a do while loop for $20,000. You're basically just handing your money away for free. But believe it or not, I think a lot of students do actually enroll in these very expensive boot camps just because their parents are paying for it, and they go and say, I've learned C++ in 60 days or over summer. But you guys having actually done C++ properly, how difficult it is, or how many different things there are, right? Not just one small track that they tease out and teach, right? Because if you look at a boot camp for game development, for example, right, using Unreal, I see they run it like in 2 days, 3 days. You come here and you develop a game and go home with that game, right? But if you look at an engine or any platform, really, it is a general purpose platform meant to help you develop thousands of products, right? Uncountable number of products, but they've taken one product, right? One game or one thing, maybe has a lot of examples, but still, even with variations, it is one small track. And that's all you're going to learn in those 2 days, right? You'll learn how to do that. But that will never, ever give us a good intuition about how to build a general product, right? You have to follow that path, you have to follow that $20,000 boot camp like 50 times, right? So that you have traversed many different paths. Then you can start to abstract out what's common between all these boot camps. What are they trying to teach? Right? And then you'll say, my gosh, I paid like $1 million with all these boot camps, but what they were trying to teach, I could have just gotten for $270 at Foothill College. Because it's all free on the internet, right? So if you have any questions like before, you can feel free to convene a lecture like yesterday. I'm happy to do it. And if I come up with any more interesting problems, absolutely, I will make sure to put them in front of you so you can take a crack at it. Okay. But the midterm, I think, is a pretty easy test, especially since if you're really serious about it, you'll get one more crack at it, and if you've done a good job, reasonable job. Yeah, I'm in favor of grading by effort, in the sense that if you're willing to put the effort, you should be given as many tries as possible within the time frame allocated to me for this course, right? So if Foothill says you have to submit the final grades by December 15, okay, I'm willing to give students as much time as possible to keep doing the same thing over and over again and failing many times repeatedly until the last minute when I have to enter your grades and tell Foothill it's all done. But I'm not in favor of saying, right, because of all the difficulties of the current environment, you can pass the course without having to put the effort, right? So that I don't think will work in your interest. I think grading by effort should basically be, it's not one try anymore, right? You can't, or the deadline has been relaxed, but you should, the only way to pass is by completing the assignment, but you get more time to do that. So absolutely, right? Anytime before the end of class, end of the course quarter, feel free to ask me questions if you have, even if they're going to be related to follow-on courses that you're going to be doing in 2B. And by the way, I asked Beta and Ram to cancel all other competing sections of 2B. Well, no, I should say competing sections and all other. But I basically said, 2B, let's try an experiment where I'm the only one offering 2B in a quarter, right? So students don't have a chance to flock to an easier quarter of 2B, having not done a good job at 2A. And then they'll just be set up for big time disappointment, right? It's better to be disappointed when you're in college, right? And not good to be disappointed when you start working. So if you are not disappointed in college saying, well, I thought I knew it, I didn't know it, I got to learn. I wanted an A, I only got a C, right? And that's a disappointment, that's okay. It's safe disappointment, right? You can always go back and fix it. But you got to fix it, right? But if you are disappointed that you got a C and you complained and said, the teacher is no good, or my grading was unfair, I need to get an A, and you got an A, because at the end of the day, if it's too much work for me, I'll just give you an A. Right? Because what am I doing as a teacher? All I'm saying, if I give you an A, is that, what, this student is being too difficult for me. Let them, let Google or Netflix or Amazon or Microsoft deal with their difficulty, right? I'm just going to give them an A, and they can go and they can waste like 5 hours of, software engineer time in front of a whiteboard, right? And let them decide that this guy is no good, right? And why? And that's going to be disappointing to you, right? Because at that time you're going to be interviewing and people are going to be expecting you to get a job, pay your way and all that. That will be a more bitter disappointment than if you just got an A now, or, C now, and you had to tell your friends or your parents, your guardians or your uncle and say, okay, I got a C, how can I get an A, right? And I think that'll be a whole lot better for you. I think, all right, maybe that's not the case, but certainly in my case, if I were in your shoes, that's what I would feel. And by the way, any conceptual questions you have relating to this, or even program complexities and things like that, those are interesting to me too, right? So feel free to schedule a lecture, even if it's offline, off schedule, right? Like Jared and Agnes and Co did last class. Where's Neelesh? Neil was supposed to be here because he was the guy who started coordinating the free class. Anyway, so feel free to schedule these classes. I'm more than happy. I have time now, so I'm more than happy to schedule an hour or 2 hours and sit down with you guys like this, right? Work through a problem. Maybe we can take a challenge problem and work through this. And maybe, if you guys are going to continue on with me, maybe we'll have increasing scope for these kinds of things, right? Maybe in 2C, if you're in 2C, maybe we'll say, let's take this acyclic graph. Acyclic is a spanning tree. A spanning tree is basically a completely connected graph where there's no loops, right? Because, it's really secure. If you have a tree, an acyclic graph, you can do a lot of things with a great deal of security, right? Because think about it. If you have a maze and there's loops or, in the maze, like a catacomb, then you could basically be trapped in there forever, right? Because you could be retracing your own paths. But if there's no loops, you can come up with an algorithm, a simpler algorithm anyway, that you can effectively exhaust everything and come back. And so if you have a graph that has loops in it, there are certain algorithms that you have to be a whole lot more careful, and there's a whole lot more housekeeping involved in making sure those algorithms work, right? But if you don't have loops, it's called a spanning tree, meaning it spans everywhere, it touches every single node, but there's no loops, right? So you can be like totally carefree and go walking around and saying that, I will never ever retrace my path here. If I ever need to, I'll just bump into a wall and then I can retrace my path all the way back to source, right? Or, like that. So, and there's lots of interesting algorithms we can do with spanning trees. And so maybe if you stick around with 2B and 2C, maybe we'll implement a quest like that, that involves a spanning tree, right? And maybe we'll come up with a story that says, some guy has to walk through a forest and discover all these wonderful things, right? But it's like a spanning tree. And you have to, and so we can create a quest like that and weave in the algorithm. There are many algorithms for finding spanning trees, right? Or reducing a graph into a spanning tree and or removing cycles in a graph. Right? It's an interesting problem, isn't it? Because if you are given a graph and people tell you, well, you know what, this graph, every link has a cost associated with it. Every link is a road, right? And roads have tar and everything on it, and it's costly to maintain. But some roads are more expensive to maintain than other roads because it has concrete. So they say, here's a brand new city. I just want to make sure that every town, every little place in the city is connected, but I don't want any loops because it's redundant. If you have a loop, you have more than one way of getting somewhere, right? So I want to say, get rid of all the loops, but get rid of all the, make this a spanning tree, minimum spanning tree, right? Get rid of all the most expensive roads, right? But still have the city completely connected. So that's an interesting problem, isn't it? Because now you have to identify which arcs you can get rid of for, so that the cost will all be kept minimal. So those are the interesting kinds of things you can start looking at. And it's not just to do with graphs and roads and civil engineering, right? But these kinds of things prop up not just in, quantitative life, they also prop up in qualitative life, right? So many times you have blocks in achieving our goals. And then this kind of thinking will also help us identify things that we shouldn't do, right? So that we don't end up with a big disappointment, right? But still at the same time, not shut off doors. Because life is full of opportunities, doors that can be open or shut, and we want to have all the doors open. Everything should be connected, everything should be reachable, but at the same time we want to have certain places that we never want to go to and not take risks at all, right? So this kind of thinking filters over your neural structure, and that you start thinking about it everything in this kind of way. Iterative thinking, I really think, is not really taught early on in many schools. But I think it is a new way of thinking, not a new way, it's a different way of thinking, right? I'm pretty sure even in ancient civilizations, it was recognized as a different way of thinking about things. But for some reason, we seem to place a greater weight on this analytical mode of thinking where the solution has to be immediately obvious, right? But I think that if we start introducing that early on with children, who knows the kinds of problems we'll solve, right? What time is it? Well, it's close to 10 o'clock and you guys are still around. Most of the time I just rely on you guys for telling me that the time is up. Fernando, are you here? Okay, Fernando's not here. So if you guys, any of you talk to Fernando, ask him to reach out to me. And I'm here. Take the midterm in the afternoon, okay? Just chill in the morning and get together in groups, maybe, and talk about plus. The best thing to do would be, one of you come up with a problem and ask someone else, and they would tell you the answer and give you another question, right? You can, and you can just be bouncing questions around. Some of the questions will be silly questions, right? Obviously, but don't worry about it. So we want to have a mix of silly, interesting, informative, useful, all kinds of questions just bouncing around. Lots and lots of questions bouncing around, and you're bound to come across at least 4 or 5 questions that may help you in the midterm, right? Just come up with, I think by teaching someone, you learn more than learning as a student, I think. So by coming up with these problems to ask other students, you may actually discover something interesting about these things, right? So come up with interesting problems and share them. And if it's an interesting enough problem, we'll just incorporate that into a test or a quiz later on in 2A, right? And you'll ask it in the forums, and I'll say, hey, that's really cool. It's going to be a future student's midterm question, all right? So, and it'll be on Reddit. So lots of fun things we can do. Anyway, it's past time. I should really let you go. I'm going to be here today, and you can call me back anytime.
All right. Have a good day.
You too. All right.
Yeah.
So enjoy the rest of the day. Best of luck for your midterm. And I'll see you guys on Tuesday.
Thanks so
all right.
much.
All right. And see you on Tuesday. Bye.
Bye. See ya.
See you.